In our next unit, we're going to be analyzing graphs using derivatives. And this is just an introduction to it, and you should have access to all of this from stuff we already know. Although there are a few vocabulary words, I'm going to go into this one in some depth. Some things to remember for this homework. F prime is the derivative of f. It tells you the slopes of the tangent lines of f. And if f prime is above 0, that means the slope of the tangent line is positive. And if it's a positive graph, it means that f must be increasing. If the slope of the tangent line is less than 0, then f must be decreasing. So increasing versus decreasing can be found by the derivative. Also, the second derivative, a couple things. First of all, it's the derivative of f. And if the second derivative is 0, that must mean the slope of the tangent line of f, because it's f prime prime. That's what the second derivative is. So it's the slope of the tangent line to the graph of the derivative is positive, which means that f prime must be increasing because the slope of the tangent line to that graph is positive. And remember earlier this year we said that f prime prime is greater than 0 means that f is concave up. Basically, if the slopes are increasing, the function is curving upwards. Also, if the slopes are decreasing, the slope is curving downwards, and that makes the function concave down. So if the second derivative is less than 0, the slopes of the tangent lines to the graph of f of x are negative, and f is concave down. All right, so use interval notation. This is the one that uses brackets and parentheses for all intervals. We've got a graph of f of x, so this is f of x shown to the right, and it says that f has a local maximum value when x is negative 1/2. So when x is negative 1/2, this is a local maximum value. This is a new vocabulary word, and it just means that this point is higher than the nearby points. That's where the word local is coming in. Okay, what are the zeros of f of x? Zeros, we should know from Algebra 1, is another vocabulary word for x-intercepts. It's the place where f of x is equal to 0. And that occurs here, here, and here. Again, before you watch these videos, you should always be making sure you can do as much of this as you can by yourself. Any questions you get help from on the video, you need to go back over later and think to yourself, like cover up your answers and say, all right, do I now know what the zeros are, if you use this for help. So the zeros occur when x equals -2, 1, and 6. Those are the zeros of f of x. On what intervals is f of x positive? So f of x is positive just means that f is above 0, and it just has positive values. That happens here and here. And so here we need to use interval notation. So f of x is positive on the interval from -2 to 1, union, there's another part, so between -2 and 1, that's where f of x is positive, and also from 6 to infinity. Notice that I use parentheses here because it's not positive at -2, it's equal to 0, and it's not positive at 1. Okay, on what intervals is f of x less than 0? So where is f of x below 0? And that's here and here. And so that's going to be from -infinity to -2, and from 1 to 6. Okay. Now, this next question gets fun. We're now talking about f prime of x. Where is f prime of x equals 0? So this is, we don't have a graph of f prime of x, but we can connect to the graph. F prime of x is the slope of the tangent line. So this is saying the slope of the tangent line must equal 0. So where is there a tangent line where the slope is 0? Well, that happens in two places. Right here, the slope of the tangent line is 0. We can tell that because it's turning around. So it went from a positive slope to a negative slope. Here there's a 0 slope. And there's one more point right here. The slope of the tangent line is 0. If you zoomed in on this really, really far, you'd see that it's just a horizontal line right there. Okay, so where is f prime of x equal to 0? That happens at, well, what is this value right here? We know that the local maximum value happened at x equals -1/2, and that must be where the slope of the tangent line is 0. So x equals -1/2, and x equals 4. where is f increasing? So increasing means it's going up as you go from left to right. And so f is increasing all along here until we get to here. And then f is increasing from here to here. Now, on increasing, I'm going to do something a little weird. So it's increasing from negative infinity to negative 1/2. That's where it stops increasing. We include the end point for an increasing function. So it's increasing from negative infinity all the way until negative 1/2, and we include the negative 1/2 there. It's also increasing then again from 4 to infinity, and obviously we never include infinity in our interval because we never get to infinity. So it's increasing from negative infinity to negative 1/2 and from 4 to infinity. And now, all right, my dogs are playing around in the background. This might get loud in a second, hopefully not. On what intervals is f prime less than 0? This means that the slope of the tangent line, so slope of the tangent line is negative, which means that the function must be decreasing. So decreasing is what this means. So if f prime is less than 0, that means the function is decreasing. And let's see, the function is decreasing right here from negative 1/2, when x is negative 1/2, until x is 4. We already talked about local minimum. I'm going to let you guys do this on your own. Is there an absolute minimum? That means, is there a value that is lower than all the other points on the graph? And the answer is no. There is no absolute minimum. This is a local minimum right here, but it's not the absolute minimum because there's lower points over here. And in fact, there will never be a lowest point because of this arrow at the end. The values are going to keep getting lower and lower and lower, and so there is no absolute minimum value. All right, this second part, we have a graph of f prime of x. This is no longer a graph of f. This is a graph of f prime of x. So, for instance, what this point means, let's actually choose a different point. I'll choose this point. What this point means is that when x equals 3, f prime equals 9. And what that means is that when x is 3, the slope of the tangent line is 9. So f has this very steep slope. Another example would be like right here, when x is negative 3, f prime is negative 8. And so that means on the graph of f, the slope of the tangent line would be a negative 8. You know, so maybe you have a graph of f that looks like this, where there's the slope of negative 8. All right, so where is f prime greater than 0? Well, we have greater than or equal to 0. All right, give me 1 second. Dogs, hey, stop. All right, where is f prime greater than or equal to 0? That means we've got this graph here. We just need to see where it's above 0. And so it's equal to 0 right here. It's equal to 0 right here. And everywhere in here, it's above 0. So f prime is greater than 0 from negative 2 to infinity. We only need a single interval because it never gets below 0. And remember that if f prime is above or equal to 0, that tells us that f is increasing. So f is increasing from negative 2 to infinity. I'll skip some of these. F has a local minimum value where f changes from increasing to decreasing. We don't have f. We have f prime. So we're not looking where f prime changes from increasing to decreasing. This is not a point we care about. We're looking for where f changes from decreasing to increasing. Well, how does f prime tell us whether f is increasing or decreasing? If f is decreasing, then f prime must be less than 0. If f is increasing, f prime must be greater than 0. So we're really looking for where does the slope of the tangent line change from negative to positive. And I hope you can see that'll be a minimum value. It makes this local minimum value when the function changes from decreasing to increasing, which means when the slope of the tangent line changes from negative to positive. When the slope of the tangent line changes from negative to positive, there will be a local minimum. And so we're looking for where is f prime changed from negative to positive. And right here, this is the point where f prime changes from negative to positive. F prime was negative, now f prime is positive. So right here, at x x equals -2, that is where there's a local minimum value of f. Notice this is not a minimum value on f prime, it is a minimum value of f. All right. I'll answer this next one for you too. F has a local maximum value. So that's where f changes from increasing. So f prime changes from greater than or equal to 0 to less than or equal to 0. The slope of the tangent line changes from positive to negative. And so we're looking for where does f prime change from positive to negative. And here's where f prime is positive, and it never becomes negative again. And so this is telling you that the slopes of the tangent line were positive, but they never become negative. And so we never have a place where f goes from increasing to decreasing, and so there is none. All right. F prime prime is the derivative of f prime of x. So where is f prime prime greater than 0? Well, that's where f prime has tangent lines that are above 0. So f prime must be increasing. This is f prime prime, right? So the derivative of f prime. We have a graph of f prime. We want to know where the derivative of that graph, f prime prime, is above 0. So that's saying where is the slope of the tangent line greater than 0, which is saying that f prime must be increasing, and so f prime is increasing from negative infinity to -1. This is where f prime is increasing, and therefore the derivative is positive. F prime prime is positive. And then again, from 1 to infinity, f prime is increasing, which means that the slope of the tangent line, the derivative of this graph, the derivative of f prime is f prime prime, that's where that's increasing. So if f prime prime is greater than 0, that means f is concave up. So f is concave up on that same interval where f prime prime is greater than 0. This might be a little confusing at first. It will not be confusing when you get good at it. These are fairly easy questions once you know what you're doing. The last vocabulary word is critical values. The critical values of f of x are the x values where f prime of x is equal to 0. Or there's another way for there to be critical values. We'll talk about it next class. What are the critical values? Okay, well, we want to find the critical values, and the critical values are where f prime is 0. So this is just asking, where is f prime equal to 0? So f prime equals 0 when x is -2 or 1. So f has critical values at x equals -2 or 1. All right, hope that helps.